Hello viewers, welcome to the another lecture of Digital System Design. We were learning module 1, that is digital logic, and the contents of today's lecture will be: we will understand the concept of minterms and maxterms. Then we will understand what is sum of product and product of sum forms, standard and canonical forms, and how to convert the standard into the canonical forms. So let's begin. Let us begin from the concept of minterms and maxterms. So as you can see, I have written that minterm corresponds to sum of product. All right. So we will see it later on that why I am saying so. But always remember that minterm corresponds to sum of product. All right. And in midterms, one is prioritized. That means, what I mean to say by prioritizing one in midterms, I mean to say that the variables which are one, they are in true form and zero is in the form of complement. So I show you when we will write the mean terms, this concept will be clear. But remember that in the case of minterms, one is given the priority. That means variables with one value are in true form and with zero value are in complement form. And minterm corresponds to sum of product. All right. And in the case of minterms, the operation that exists between the variables is product. All right. So the variables are combined with and operation in the case of minterms. So these one or two points we have to remember that minterms corresponds to sum of product, whereas maxterms corresponds to product of sum. In the case of midterms, one is given the priority, that means one is in true form, zero is in complement form. And in the case of max term, zero is the true form, one is the complement form. All right. And in the case of midterms, the variables are combined with the AND operation, whereas in the case of max terms, the variables are combined with the OR operation. So this we have to always remember. Now, as you can see in the example, I have taken first example as f is equal to a plus b dot b plus c. So first of all, this is product of sum. Why product of sum? You can see that the variables are combined with OR operation and in between the terms we have the product operation. So this is product of sum. Alright, and this is sum of product. Now let us understand how to write the minterms in max terms. For example, we have three variables in any expression. The three variables be x, y, z. So that means there will be eight combinations for them. So I have already written the eight combinations for the three variables. Now let us see how to write the minterms. As we have already discussed, in the case of minterms, the operation that will exist between the variables will be the AND operation. Alright, so let us write the minterms for each combination. So for the first combination where x, y and z all are 0, so I have told you that 1 is the true form in the minterm and 0 is the complement form. So because all are 0, therefore it will be x bar, y bar, z bar. And the operation that will exist between the variables will be the product or the AND operation. Similarly, for the next combination, it will be x is 0, so x bar, y is 0, so y bar, and z is 1, so it will be only z. Similarly, for another combination, x bar, y, z bar. For another one, it will be x bar, y, z. Then x, y bar, z bar. Then x, y bar, z. Then x, y, z bar. And the last one will be x, y, z because all were 1. So they will occur in their true form. And we denote the minterms by small m. So for there are eight combinations starting from 0 to 7. So they will range from 0 to 7. So it will be M0, M1, or you can say minterm 1, minterm 2. So these are the minterms. Now let us see how to write the max terms. In the case of max terms, the operation that will exist between the variables will be the OR operation. And there, in the case of max terms, 0 will be in the true form, 1 will be in the complement form. So for the first combination, x, y, and z all are 0. So therefore, 0 is in the true form in the case of max terms, and the operation that will exist between the variables will be the OR operation. So the max term for the first combination will be x plus y plus z. Then for the another combination, as x is 0, so x, y is also 0, so y, but z is 1, so it will be z bar. So in the case of max term, 0 is the true form, 1 is the complement form. In the similar manner, let's write it for all the possible combinations. So these are the max terms, and the way to denote the max terms is by capital M. So they will range like M0, M1, M2, so these are the max terms. So this is the concept of min term and max term mainly. I hope you all might have understood. Now let's take a question where there is an expression given f is equal to a plus bc. Now, in the above part, we haven't taken any output. I just explained you the concept of minterms and maxterms by the variable combinations. Now, we have a proper expression over here for which the output f is equal to a plus bc. So, here we have to calculate a plus bc are the variables. As there were three variables, so I have made eight possible combinations for them. Now let's calculate the output f for the given expression, that is a plus bc. So putting the value of a, b and c in the above expression, we get for the first combination we get 0. Then for the another combination a plus bc we again get a 0. So these are the outputs for the above expression. Now what I have to do in the question, I have to find the minterms and the max terms. Now as I have the output over here, so I will write the minterms and max terms only for the output. I do not have to write the minterm and max term for each combination. I will only write the minterm and max terms for the output. So in the case of minterms, we have an output and only one has to be prioritized in the case of minterms. So we will write the minterms only for the output. So in the output we will only give the priority to one, and only for those terms we will write the minterms. So for each one, let us see the corresponding combination. Alright, so what is the combination? Let me write down the heading that I am going to write down the minterm. So the minterms for this one output, the corresponding combination is A is 0 and B and C is 1. So it will be A bar B C. Then for the next one, it is A B bar C bar A B C. And if I number the midterms, so the first one will be M0, M1, M2, then M3, M4, M5, M6, and M7. Okay. So, but for the output, we had ones only for these combinations. The output was one only for these combinations. So, for the above expression, we have the midterms only on number 3, 4, 5, 6, and 7. So small m for minterms, and I have directly written the numbers for which the minterms were falling. And preceding this m, there is a summation sign. So summation indicates sum of product, or you can say simply sum. So this summation indicates sum of product. Alright. So now if I were asked to write the sum of product form, then I will combine all the minterms and will write like this. So this is the SOP form where all the minterms are combined together. So this is the sum of product form. So I have calculated the minterms as was asked in the question, and I have also shown you how to write the sum of product form where you have to combine all the minterms. Now the second part of the question is that I have to write down the max terms also. So as you can see, in the case of max terms, 0 is prioritized. So we will write the combination of max terms only for the those cases where the output is 0. So let's see the corresponding combinations of each output where it is 0. For the first 0, the combination is 0, 0, 0. And for the max terms, 0, 0, 0 means A plus B plus C. So this is the max term. Similarly, for the next 0 output, we have 0, 0, 1. That means A plus B plus C bar, as we discussed earlier. And for the third output where it is 0, the combination is 0, 1, 0. So it will be A plus B bar plus C. So these are the three max terms for the above expression. That means M0, M1, M2. So the max terms are, for this F, the max terms are capital M, 0, 1, 2. And preceding M, there is a sign that is pi, which indicates product of sum. That means if I have to combine all the max terms, then I will combine them in the product of sum form and it will be written as, let us again see what were the max terms. A plus B plus C dot A plus B plus C bar dot and A plus B bar plus C. So this is the sum of product form. So we have hereby calculated the minterms and maxterms. Also, we have discussed how to write the SOP and POS forms. Now, let us move on to the another question. Again, you have a specific number of variables here and you have an output y. That means y is a function of three variables, that is a, b and c, and in the question y has been already given to you. When you have to find the minterms and maxterms, you just have to look at the output and you have to give the priority to 1 if you have to calculate the minterms, and you can prioritize 0 when you have to calculate the maxterms. So for each output 1, you have a corresponding combination of A, B and C. So for the first output 1, we have a combination of A, B, C such that A is 0, B is 1 and C is 0. So let's write down the minterm for this. So minterm for this is A bar, B, C bar. For the next one, the minterm is A, B bar, C bar. Then only these four terms are the minterms because y is 1 only for these minterms. Alright. And the remaining ones. And the remaining ones you can see that the output is 0 for the remaining cases. So that will be the max terms. So if you want to write the max terms as well, then for the first combination, as you can see, you have 0, 0, 0. That means the first max term will be A plus B plus C. Because in the case of max terms, 0 is the true form, 1 is the complement form. Another max term will be A plus B plus C bar. Another one will be A plus B bar plus C bar. Another will be A bar plus B bar plus C bar. Alright, so there will be four max terms and four min terms. If you have to write the sum of product form, you can combine all the min terms. And if you have to write the product of sum form, you can combine all the max terms. So if I have to simply write the min terms, so y as a function of a, b, c is equal to summation m because I am going to write the minterms. So, which is the what is the number of the first minterm? Starting from 0, 0, 1, 2, then 4, 5, 6. So these are the minterms and the remaining ones are the max terms. That means 0, 1, 3 and 7. So these are the max terms. And if you have to write SOP and POS form that we have already discussed, that you have to combine minterms for SOP and max terms for product of sum. That is POS. So this was the concept of minterms and max terms as well as sum of product and product of sum. Now let's move on to the next topic, that is standard and canonical form. So basically, standard and canonical forms both are classified into the two types further, that is SOP and POS. That means standard sum of products, standard product of sum. and then canonical sum of product and canonical product of sum. So for the first thing that you have to understand is what is standard form. If in an expression at least one term exists such that it does not contain all the variables. See, I have given you the example also. First of all, look at the example. We have f is equal to a plus bc. So it is sum of product form, and there are two terms in this particular expression. This is term 1, this is term 2. As you can see that in the first there are total three variables in this expression. And in the first term, B and C variables are missing. That means in the first term, all the three variables are not present. As well as this is the same case in the second term. That means all three variables are neither present in the second term. So therefore, when at least one term exists such that it does not contain all the variables, that means even more than one term can be so, but at least there is one term which does not contain all the variables, then it is a standard form. And because it is in sum of product form, so it will be in standard sum of product. It is the standard sum of product form. Similar is the case in the second example. As you can see, the second example is a product of sum form, and there are two terms again in this expression, and both the terms do not contain all the variables. That means in the first term, C and D variable is missing, and in the second term, A and B variables are missing. So this is also standard form, and this is standard product of sum form. So I hope standard form is clear. Now let's move on to the canonical form. In the case of canonical forms, all the terms that will exist in the expression, they will have all the variables present in them, either in their true form or in their complement form. That means, as you can see in the example also, this is sum of product form having two terms, and in both the terms, all the variables are present. That means, looking to the expression, the total variables are three, A, B, and C, and in both the terms, we have all the variables. That is why it is a canonical sum of product form. Similarly, another expression, again, it has two terms, and in both the terms, we have all the variables either in their true form or in their complement form. So this is also canonical form, and this is canonical product of sum form. Now, let us see how to convert the standard forms into the canonical forms. Now, there is a question given. The first question is that f as a function of a and b, and the expression is given a plus b. So this is sum of product form. So there are two variables and there are two terms. In the first term, one variable is missing, that is b, and in the second term, a variable is missing. So how to convert it into the canonical form? What we can do, this expression is similar to a dot 1 plus 1 dot b. I hope that you all will agree. And you can replace 1 in terms of b and its complement. As we have already learnt in the formulas of Boolean algebra, that any variable when added to its complement will give you 1. So we can write it like this. Similarly, we can write 1 in terms of a and a bar, and it will be like this. And now simply we have to open the brackets. So it will come out to be AB plus AB bar plus AB plus A bar B. Now we do not have to reduce or simplify this expression further by using the Boolean algebra formulas. We only have to do one thing, that if any term is occurring twice or more than once, then we have to only write it once, because according to Boolean algebra formulas, we know that A plus A is equal to A. Alright, it's not equal to 2A. So what we have to do, we simply have to combine them and write them only once. We do not have to apply any other formula and reduce the expression, because reducing the expression is not the objective right here. We have to convert this expression into the canonical form, where each term will contain all the variables of the expression. So this is the canonical form. I hope it is clear. Now let's move on to the next question. In the next question, as you can see, there are total three variables and there are two terms, and in both the terms, the variables are missing. So in the first term, two variables are missing, that is B and C. So we can write A dot 1 dot 1, which is nothing but A. And similarly in the second term, as A was missing, so I wrote only 1 instead of that. So we can replace in the first term 1 by B plus B bar and also another 1 by C plus C bar because we have to furnish each term with all the variables. Similarly, in the second term, we can write A plus A bar dot BC. Now simply open the brackets. Now there are again two terms which are occurring more than once. So let's write them only one time and leave the expression as it is. So now we have all the terms containing all the variables, and that is what we wanted. So this is the canonical form. Now let's move on to the next question. Now this has to be converted into canonical form, and this is product of sum form. So it should remain in the sum product of sum form itself. You do not have to convert it into sum of product by opening the brackets. So as you can see, there are three terms, that is first term, second term, and the third term. In the first term, C variable is missing. So I hope that we can write it as A plus B bar plus 0 dot. In the second term, A is missing. So 0 plus B plus C dot A plus 0 plus C bar. Now we can replace 0 by C dot C bar according to the formulas of Boolean algebra. Similarly, we can replace here 0 by A plus A dot A bar. Similarly, we can replace here we can replace here 0 by B dot B bar plus C bar. Now, you can use distributive law. You do not have to open the brackets because if you will open the brackets, it will get converted into sum of product. But the question was in the form of product of sum. So you have to keep it in the product of sum form only. So what to do? Just use distributive law, which says that A plus CD is equal to A plus C into A plus D. We discussed it when we discussed the Boolean algebra formulas. So how we can write the first bracket, how we can open it? We can write it as A plus B bar plus C, then A plus B bar plus C bar. It will be dot here. So if any of the two terms are occurring more than once, then we will only write them once. So these two terms were occurring. So let's keep it only once. So this is the canonical form. The question was given in product of sum form, and we do not have to change the product of sum into sum of product. We just have to convert it into the canonical form. And here we have used the distributive law to do so. So this is the concept of canonical and standard forms. I hope that you might have understood. Now there is one more question, last question to convert into the canonical form. I hope that you all can do it. So just do in the same manner as we have solved this question, the previous one. So I'm directly writing the answers over here. You can verify your answers and write in the comment box that whether you have got the answer or not. So I hope that this video might be useful. So if you like the video, then like it, subscribe the channel and share the channel link with as many as you can. Thank you all.